Okay, good morning everyone. Uh, in today's class, we are moving towards packages. Just let me. Okay. This was what we did last. That is, we finished our take on modules, and in today's class, we are moving towards uh, uh, NumPy packages. Let me quickly summarize what we have done so far. Just 1 second. Okay. So far we have seen the introduction to data science, and within the introduction to data science, I in short explained what is the use of data science, what is the need, what are the probable reasons that we are moving ahead, and job scope and so many other things. We further saw introduction to Python, which is our basic programming language that we'll use for exploring data science topics. And within introduction to Python, we saw basics of Python. So basics of Python, like we saw operators and control structures, we saw loops, we further saw functions and modules, and we have also seen different data types, that is strings, lists, tuples, dictionaries, sets, etc. And now we are moving towards the next stretch, which is packages. Okay. And in the last class, we also saw how to create our own packages. Now we will look at what are the most commonly used packages within the data science community. Okay. And our first stop at this journey is a package called as Numpy. Okay. Uh, and this will be the topic for today. We will be talking on what is NumPy, how we can use it, and what are the different uh, caveats around it, and so on. Okay. So that will be our agenda today. Uh, Let me move to the next slide, and I'll show you what I mean. Okay. So this is the logo for NumPy. Okay, and NumPy basically stands for something called as numerical Python. Okay. And it's a very common package. It's a very famous package within Python. So everyone who has worked on Python, I would like to believe that they would have been exposed to NumPy to some level or the other. And NumPy is also a foundational package for most common data science packages. What I mean by that is many commonly used data science packages like Pandas, Scikit-learn, even Matplotlib for the matter, they use NumPy as their base, NumPy as their foundational package to work on. So Pandas, you'll read a lot about Pandas, that many of the things within Pandas, the rows, the implementation, the loops, are actually implemented within NumPy. So hence that makes it a very good place for us to start and looking at NumPys. Additionally, NumPy is a high performance multi-dimensional array for vectors or matrices. Okay, high performance multi-dimensional arrays for vectors or matrices. So by high performance, I mean that they are very fast, they are very compact, and they are highly optimized so that they work very well, especially in the case of arrays and vectors and matrices. Okay. The key features of NumPy that we'll be looking into is we have something called as ND arrays, which stands for n-dimensional arrays. Okay. The NumPy uses n-dimensional arrays, which are very fast, they are convenient, and they're space efficient as well. And we will look at broadcasting and vectorization. So maybe before going ahead, let me ask you: have any of you heard of a software called MATLAB? Okay, excellent. So especially if you are coming from engineering backgrounds, um, many engineering fields, they use MATLAB as a reference, And the good point is, if you have some experience in MATLAB, transitioning towards, so far, if you have known MATLAB, you would have seen so far also, transitioning to Python is very simple. Many of the codes, they look very similar, some syntax change here and there, but the concept is very similar. And further, if you want to go more towards that similarity, when you move towards something called as NumPy, it makes it further similar. Okay, NumPy uses multi-dimensional arrays of vectors and matrices. Similarly, MATLAB also uses a lot of matrices and vectors for their calculations and so on. Okay. So if you are close to these two terms, you should find it relatively very easy to use NumPy as well. Let me go ahead and explain some ways that we can create elements of NumPy. So the basic element of NumPy is something called as ND array, which I said stands for n-dimensional arrays. Here are two cases where we can create rank 1 and rank 2 arrays. And what I mean by rank 1 and rank 2 arrays are how many dimensions we have. Okay, so this is, let's say, rank 1 arrays are basically arrays that are written in uh, uh, one dimension, either rows or columns. Okay, so in this case, the way that we create NumPy arrays is writing NumPy. Okay, so maybe even before here, there is one step missing, is we have to import the package NumPy. Okay? And the way we'll do it is we'll write something like this: import NumPy. Okay? And when you import NumPy, generally people use an alias as NP for using NumPy. So we will do this as import NumPy as NP. Okay. And when we import this as NP, then we can use all the functions of NumPy by calling functions like np.something, np.something, and so on. Okay. If you're starting on a new system and you have not installed NumPy so far, the way that you would install NumPy is writing this command. In your Jupyter notebook, you can write exclamation pip install NumPy. Okay. So for most people, this should do the task. Just in case you get stuck, you're not able to do it, you do a quick Google search and you will get a way of how would you install packages on your system. Okay. The first step would be to install NumPy. If you have installed Anaconda, or if you're working on Google Colab, both cases you will not have to do this because NumPy comes as a comes within those things. Okay, so you would not have to install it separately. But let's say you want to install it separately, you can write this into your Jupyter cell and execute this, and you will get your NumPy installation. Once you have installed NumPy, you can call that to your program by writing import NumPy as NP. Now what I'm showing you here is the first function of NumPy that we are looking. Okay. In this function, we are trying to create a rank 1 array, a rank 1 ND array. Okay. To this function np.array, we are passing one input. The input is a list. How do I know it's a list? By looking at the open bracket and square bracket here. So we see, okay, we see open and close brackets to get our list. This list has multiple elements: 1, 2, 3, 4, 5, 6, and you pass this to np array. And what it creates is it creates a variable called as n1, and this is how n1 looks like. Okay, I can see n1.shape. I can do n1.shape because now n1 is basically an n-dimensional array. It's an ND array, so it comes with addition functionality. Dot shape is one of the things that comes with that, and I can quickly look at what is the shape here. The shape here is in the form of a tuple, and this tuple has just one number. Okay, and the one number shows that there are 6 elements inside n1. Okay. They are 1, 2, 3, 4, and 5. 4, 5, and 6. Okay. Similar to creating a one-dimensional or a rank 1 ND array, we can also create a rank 2 ND array. Okay. So if we come here and you see n2 is equal to np.array, and here we are passing again one element. That one element is a list which is made up of two lists. Okay, the first list is again three elements having 1, 2, 3. The next list has three elements having 4, 5, and 6. And even though passing a list of lists to NumPy, what we see is NumPy has automatically placed it into two rows and three columns. Okay, it has placed it into two rows and three columns. The first row has the elements 1, 2, 3, which is the first list that we passed here. And the second row is having the values 4, 5, 6, which is the second list that we passed here. When we do n2.shape, we can see that there are two rows and three columns. Okay. So these are basic ways of creating arrays, a rank 1 array and a rank 2 array. Notice this here, that a rank 1 array is in the form of a tuple. The shape is in the form of a tuple with one element. And for a rank 2 array, the shape is in the form of a tuple with two elements. Now, additionally, there are several ways of creating NumPy arrays. Okay? Of course, this is one way. These are ways of creating NumPy array. But many of the times, we would want to create NumPy arrays for a big quantity. Okay, so a large number of values. In which case, if we have certain functions, then it will be very, very useful on how to. Okay, if we have functions, then it will be very useful to create such arrays. Okay. So here we have several functions. So we have np.zeros. Can you tell me what is the type of input that this expects? So I've shown an example of how to use it. Can you tell me what is this type of input? Okay, excellent. So you're right. This is a tuple. Tuple goes as input. This tuple has two elements. First tells us the number of rows we want. The second tells us the number of columns we want. When we say 2, 2, we get the first row here as two elements of 0. And then 2, 2 gives us two columns here of elements as 0. Okay. So just as curiosity, if I want this as my answer, let me write this. I write 0, 0, 0, 0, 0, 0. For this as my answer, what do you think should be the function that I will have to write? Okay, many of you are writing correctly, but I see many people are writing wrongly as well. Okay, so for this, you see how many rows are there? There are two rows, row 1 and row 2, and there are three columns, 1, 2, and 3. Okay, and the program that you would have to write is you would have to write the same thing np zeros, and instead of this part, you would write within a tuple 2, 3. Okay, 3, 3 is not right. You would write 2, 3 for two rows and three columns. Let's go ahead. Then we have a function called as np.full, which basically creates the matrix whose dimension that we provide here. Okay, and the value here will be the value that will be used for all the elements. So if we write np.full 2, 2, it will create two rows and two columns. And the value 9 here will say that all the values will be having the value 9. Okay, so this is the way we can create any dimension size with any value that we want. Going ahead, we have an interesting function called as EYE, which basically stands for identity matrix. Okay, identity matrix basically means when I look at a matrix, and if all the principal diagonal elements are 1, then it is called as identity matrix. Okay, so here we write 2 cross 2 creates two rows and two columns whose diagonal elements are 1 and 1. If I want a 3 cross 3 matrix like this, if I want the answer as 1, 1, 1, and everywhere I want zeros, then my corresponding command would look like 3, 3. So great. This is how we have certain functions. We have some more functions, something called as ones. So the function ones helps us to create a matrix of this size, two rows and two columns with all values as ones. Okay? That is what we get here. Notice that this is not 1, it is ones. And similarly, for zeros, uh, it is not ZEROES, but only ZERO 0 and S. Okay, so that's the spelling that we have to use for ones and zeros. Going ahead, we also have a function like here. Okay, we have np.random, and then the size here. So basically what it tells us that NumPy is not just a module, NumPy is a package. Okay? And in this package, there are multiple modules. One of the modules is called as random. Within random, there is a function called as random, which takes an input like tuple and it provides us random numbers. Okay? So when you write random here, it creates for us this 2 cross 2 matrix of random numbers. With the interesting thing that these numbers will always be with the gap of 0 to 1. Okay? So the minimum value will be 0, the maximum value will be 1, and within this region, okay, or within this limits, it will create for us random numbers. Okay. So those are the those are the multiple functions that are available with us with NumPy. What I also wanted to show is I will share my screen, my laptop screen actually, and I will show you a notebook in which we will try these examples and see. So let me go here. Okay, just give me a moment. Okay. I hope you are able to see my screen, right? So I'm sharing my laptop screen with the Jupyter notebook. Can you just confirm that in the chat? You're able to see my screen? Okay, excellent. So within the screen, I'm just showing you what I've done here first is I have imported NumPy. So import NumPy as NP. We have the package NumPy loaded. Further, I'm going ahead and creating an array using np.array. So writing np.array, and I'm passing one list with 3 elements, 3, 33, 333, and that gets loaded into an array. When I execute this code, and I print the type of an array, I can see that this is an ND array. Okay. Further, if I can check the shape of this by writing print anArray.shape, and I can see that there are 3 elements within this. To access the individual elements, let me first disable annotation. Okay. To access the individual elements, I can write an array, and then within square brackets, if I write 0, I'm able to get the first element. Within square brackets, when I write 1, I can get the second element, and with 2, I get the third element. Okay, so that is the way to access the elements inside an array. Let me execute that. We can also update values by the same strategy. Okay? So if I want to, let's say, update instead of this first value 3, I'm going to update the value 888. I can write an array, and then within square brackets 0, 888. When I execute this, we can see that the 0th element, or the first element of this array, gets updated. Okay. So that is how we create rank 1 arrays. Going ahead, rank 2 arrays, same strategy. So I'm showing you 2 ways. Okay. The first way is this, another list. This is not a NumPy array. This is actually a basic array, a basic list of lists within Python. So if I write another list is equal to, I write a list which has 2 elements. The first as a list having values 11, 12, 13. The second as a list having values 21, 22, 23. And when I print another list, I can see that this is how it gets printed. If I want to see the type of this, I can write type of another list. Okay, I can see that Python tells me that the type of this variable is a list. Okay. To access the elements inside, so let's say I want to access the first element, I will have to do another list and then write 2 open and close brackets. Okay, the first bracket here tells me from this list which element I'm looking for. So I'm looking for this element, so I have to write 0. Okay, it is an index 0 notation. And then within this element, if I'm looking for this value 11, I'll have to write another square bracket with the index 0, and then I'm able to access this value. Okay, this is how you would normally do things with your base Python lists. Okay, if you look at here, I'm taking the same values, but now instead of a list element, I'm creating a Numpy object. Okay, so I'm writing np.array, and then I'm passing the same data here. Now this variable another is actually a Numpy object. Let me print the type of this object. So I can write print type of another. And when I execute this, I can see that this first line shows me that the type of this object is ND array, which is saying that it's a NumPy n-dimensional array. Now when we print another, we see what NumPy has done. To print it, it has printed it in 2 rows and 3 columns. When we had printed it using list, list had not interpreted it that way. List had interpreted it as just a list of lists, whereas NumPy interprets this as 2 rows and 3 columns. Additionally, when we look at its shape, we can look at its shape by writing another dot shape. We can see that there are 2 rows and 3 columns. Now to access the different elements inside, we have to write this command, right? So when I write another 0, 0, let me take this up. Okay. When I write another 0, 0, you can see that we are able to access a 0th row and 0th column. That is, this is row 0, and within row 0, this is column 0, which is the element 11. Okay, so keep this difference in mind. To access the elements of a NumPy array, we have to write one square bracket with the dimensions separated by a comma and writing the values. And whereas for list of lists, we have to access it using 2 square brackets. So maybe quickly, can you tell me how can I access the number 22 here? Okay. To access the number 22, what command should I write in NumPy? Okay, 1, 1. So many people are writing answers. Not all of them are right. Okay. So 1, 1 is fine, but along with 1, 1, you should also remember the type. Okay, so I will have to write something like this. Another, that is the name of my variable, and then within square brackets I have to write 1, 1. Okay, these square brackets are important. Okay, many of you were writing in curly braces. Curly braces will not work out. If you have to access the elements within the NumPy object, you have to write it in square bracket. So when I execute this, we can see that we are able to access 22 here. Okay. Another question: if I want to access 22 here, okay, so this is the element of Python list, and I want to access 22. What would be the command that I would have to write? Okay, excellent. Now you have got it. So to access element 22 here, I would have to write the name of the variable, which is another list. And then within first square bracket, I write 1. And then second square bracket, I write 1 again. And when I execute this, we are able to get the element 22. Okay. Excellent. Going ahead, we also saw some functions that will help us to create arrays, okay, which will help us to create big number of arrays as well. So we'll first look at an example of np.zeros. So when you write np.zeros, you pass a tuple with 2 elements 2, 2. We can see that we have 2 rows and 2 columns with all values as zeros. If I want 6 rows and 2 columns, I can write simply 6 and 2. And when I execute this, I will get 6 rows of zeros and 2 columns of zeros. Okay, 6 rows and 2 columns. Additionally, I can also use the full command. With the full command, the first input I have to provide is the size of the domain of the matrices that I want, and the second value is the value that in the second input is the value that I wanted. Okay, so when I write np.full 4, 2 with 3.14, it gives us 4 rows and 2 columns with 3.14. Let me change this value to maybe, let's say 3 or to 2, and let's say if I want a 4 cross 5 matrix, then I can arrange my input accordingly. 4 rows, 5 columns, and with the values of 2. When I execute this, we get here 4 rows. So this is row 1, row 2, row 3, row 4. and then 4 columns as well. Column 1, 2, sorry, 5 columns, column 1, 2, 3, 4, and 5. I can use the identity matrix like EYE. I gives here the identity matrix. When I write 4 cross 4, it gives us 4 rows and 4 columns with all the principal diagonal elements as 1 and everything else as 0. I could also go for 5 rows and 4 columns. What it would do is it will still keep the principal diagonal elements as 1 and everything else as 0s. We have a function called as once, and once gives us all the elements will be ones. Okay, so there are two interesting examples of this. Okay, in example 1, I'm calling np.once, to which I'm providing a tuple, and in this tuple there are 2 elements. The first element tells you number of rows, the second element tells you number of columns. Okay, so when I write it this way and I execute this within example 4, I print example 4 and its shape. I can see that it prints me this value as the elements of example 4, which is, if you look at here, there are 2 square brackets. Okay, the first square bracket tells us that that the 2 square brackets tells us that this is a rank 2 element. Okay, this is a rank 2 element. When I look at its shape, I can see that there are 1 row and 2 columns. Similarly, if I call np.once and I just pass one element, that is the value 2 here. Okay, I am not passing a tuple, I am just passing a number 2, and I store that into example 4b. I print example 4b. We can see that it gives us 2 values, 1 and 1, but it gives us in one square bracket. Okay, not 2 square brackets like here. And when we look at its shape, the shape tells us there are 2 elements. Okay, and the 1 value in shape tells me that this is rank 1 object. Okay. So this is very interesting. Though the output looks same for us, 1 and 1 and 1 and 1 here, these are actually 2 matrices with different dimensions. Okay. And dimensions are very, very important, especially when you want to do matrix multiplication and so on. Okay, so keep this in mind. If for matrix multiplication, even though for us this would look like 1 row and 2 columns, it is not the same for Python. Python says that this is an element with just two values. Okay, it does not interpret it as rows and columns. Okay, this is just a way of accessing elements inside. Let me go ahead. To create random numbers, I'm using np.random.random, to which I'm passing a tuple, which is 4, 2, 4 rows and 2 columns. You can see that these are randomly generated. Let me execute this multiple times, and you can see that every time I execute this, it gives me different random values. And you would also note that all the random values are between the range 0 to 1. Okay. We can go with any size we want. Let's say we want 4 rows and 10 columns. And when we execute this, we will have 4 rows and 10 columns. The 10, it is not fitting in one screen, so it is writing it in 2 rows. But still, you have 4 rows and 10 columns. Okay. Going ahead, we can write code to update certain values. So let me go back to 2. Okay. And let's say in this example, I'm looking at this part, which is 0.11407811, and I want to update its value with the number 5. The way I can do that is if you write example 5, 1, 1 and 5, and I execute this, I can see that this value here gets updated to 5. So, okay, someone is asking an interesting question. How am I able to execute within notes? So this is actually an executable. This is a Numpy. This is a Jupyter notebook. And the interesting thing with Jupyter notebooks is you can write code and you can write text at the same time. So to execute this cell, I am using Control and Enter. And Control and Enter will just execute the cell and keep me on the same cell. Whereas if I use Shift and Enter, it will execute the present cell and move on to the next cell as well. So to update this value, we have written this code. Can you tell me a very quick code to update this value? If I want to change this value and replace it with the number 3, what will I have to write? The name of my variable is example5, ex5, and I want to update this value, and instead of this value I want to get the number 3. Okay. Okay, there are many answers, but there are mixed answers. Let me explain. You see, to go to this location, you have to see what is the row index and what is the column index. Okay? And row index and column index are calculated using zeros. Okay, it starts with 0. So this is the first row, which is row 0, row 1, row 2, and then this is row 3. Okay, so we have reached row 3. Now looking at columns, this is column 0 and column 1. Okay, so this is column 0. So row 3 and column 0 is how we will update this value. So I will have to write the code something like this. I have to write ex5 row 3 and column 0 is equal to 3. And when I write ex5 after this and I execute this, I can see that this last element here has updated with the value 3. Okay. Just to see that you have understood this, can you tell me one more example? How can I change this number here? I want to replace this number with the value 1. Okay. If I want to change this number with the value 1, what should be the code that I write? Okay, excellent. So now you guys have got it. This would be simple. Go to row 0, row 1, row 2. So this is row 2, column 0 and column 1. So this is row 2, column 1. Okay, and I want to update the value with 1, so I equal to 1. And when I execute this, I can see that this value here gets updated with the value 1. Okay, let's go ahead. Okay, there is another function called as randint, which is within Numpy package. There is a module called as random. Within random, there is a function called as randint, okay, which takes 3 inputs: the low value, the high value, and then the size. Okay, so you see here, this is we are using keyword kind of input arguments. Okay, we are writing the name of the keyword, and then we are putting a value. So we are putting low is equal to 10, high is equal to 20, and size is 3 cross 3. That means create a matrix which has 3 rows and 3 columns, and it should have random numbers with the minimum value as 10 and maximum value as 20. So when I execute this, you can see here that all the values keep on, every execution, the value keeps on changing, and you would notice that all the values are within the range 10 to 20. So when I say 10 to 20, what it basically means is 10 is the minimum value, so values can take the value 10. But when I write 20, the numbers cannot take the value 20. The maximum value will just go till 19. It will never go till 20. So if I want 20 also to be included, I have to write 21. It's the same strategy that we used for range and for accessing slice of lists and strings. The same holds true here. When you write the high value as 21, it is allowed to take only values till 20. So if I want numbers from 10 to 20, I can write something like this. Okay. I hope you have understood this. Let me go back to my slides, and we will see the other part of the code. Okay, just 1 second. I'll share. So I'll stop sharing from here. Share my screen. Okay, have you got this? Okay, great. Someone is saying we can use range function. No, see, range function will give you your answers within a series. Okay, so when you do a range function, you say, let's say, you write range start from 10, go till 21 with steps of 1, let's say. So this will give you a list of items like 10, 11, 12 till 20. The program that I was showing earlier would give you random numbers from the range 10 to 20 in the shape 3 cross 3. Okay, so that was the advantage of getting it. Okay. Now, of course, does that mean that without that function I cannot do it? I can do it. Okay, you can write a simple for loop. You can write a function that can get you the same task. The interesting thing is, why would you want to do it when you have a function that is freely available? Okay, and this is something that we'll be using in Python a lot. Okay, we would want to take use of the multiple packages and libraries available within Python, so that you would not have to code too much. Okay, and the reason for this is, as a data scientist, you would have to do many things. Okay, you would want to use your energy and time efficiently to do something that is not available, rather than spending time on writing code that is already available. So that was just my 2 words, but then in the end, it depends upon you what you want to use. Let me go ahead and explain array indexing. So here we have 3 kinds of indexing available within Numpy. We have something called as integer indexing, slice indexing, Boolean indexing. Integer indexing is something that we have already seen. That is, how do we access individual values? Okay, so let's say we have, let's say, a matrix A with the values 1, 2, 3, 4, 5, 6, and to access several elements, let's say to access this element, we saw that we could write code like this. I can write A of row 0, column 2, and then I can access this value here. Now, individual elements is fine. Sometimes we would want to work on groups of elements. Okay. Now, to work on groups of elements, Numpy provides for us something called as slice indexing. Okay, same that we had seen in lists, we can do the same strategy here. So when let's say I want to select this entire row here, I would write the code as follows. I would write A of row 0, and columns I would write 0 to 3. Okay, so now when I write something like this, that is, for rows I want to access row 0, but for columns I want to access this part. So from our example, from our experience in Python, you would know that 0:3 basically stands for 0, 1, and 2, okay, which are the elements given here, 0, 1, and 2. So when I do this, I will be able to extract this part. You'll get 1, 2, and 3, which is the first row that we wanted to extract. Okay. Similarly, if you want to extract, let's say, this column, okay, if you want to extract 2 and 5, the code that I would write is something like this. I would say, go to A. Okay, sorry. I would say, let's take A, and what are the rows that I want? I want rows 0 and 1. So I would write 0, colon 2. That would be accessing rows 0 and 1, and column 1. So when I do this, I will get for me 2 and 5. Okay. So those are called slice indexing. Now, if you remember from our examples when we were trying to access elements within a string, what happens when we don't write certain things? When I don't write the start value, then it assumes that the start value is always 0. And when I don't write the end value, it assumes that it is the size of the string. Okay. So in this case, let's say I wanted to access this 1, 2, and 3. Since I know I'm going for the entire row, that means I'm starting from 0 and going to the last value. I could have eliminated, I could have not written these 2 parts, and still I would have got the same answer. Okay, let me rewrite this nicely. I would have to write the code something like this. Go to matrix A, go to row 0, and get me all the values in that column. Okay. Go to row 0 and get me all the columns. So I'm not writing any start value, I'm not writing any end value. So 0:3 can also be interpreted as single colon. Okay, and that will help me to get the entire first row. Similarly here, to get this value, I could write it something like this. I could write A of all values or all rows and column 1, and that would help me to extract this part. So I hope Okay, someone has written a question, but I cannot understand the question. Uh, so I hope you have understood this. Let me ask you some questions. Let's say you want to extract this element, 5 and 6. Okay, I'm interested to extract this part. What would you write? What command could I write to extract this part? Okay, so we've got mixed answers. And when we get mixed answers, I know that many of you have not got this idea. So let me explain to you this one and then I'll ask another question. To get this part, so you look at which row we are talking about. So this is row 0, this is row 1. So I'm interested in getting row 1 and which columns I'm interested in. So this is column 0, column 1, column 2. So I'm interested in columns 1 and 2 and row 0. Okay. So row 1. The way I would write this is I would write something like this. Go to matrix A, go to row 1 and fetch for me columns 1 and 2. So I could write 1 colon 3 and that would fetch for me columns 1 and 2. Okay. If you write 1 colon 2, that will get you only the first value. I want both these values, right? So I have to write 1 colon 3. Now, since I know this matrix contains only 3 elements, I need not write this 3 as well. Another way is I could write the code A 1 comma 1 colon and that would also fetch me the right answer. Okay. So when we write 1 colon, what it basically means is start from 1 and go till the end. Okay. So we can write this code and get this idea. I hope you have understood this. Okay. Let me ask one last question to confirm your understanding. Okay. Let's say I want to access these two elements, 1, 2. Okay. I want to access these two elements, the ones that are marked here in bright, 1 and 2. What is the code you would want to write to get this? Okay. Okay, excellent. So here again, I'm getting mixed answers, but but this time I can see many of you are right. Uh, Let me show you. To get this part, you would have to write something like this. You write A, go to row 0, get me all elements from the start till 2. Okay, why 2? Because you see the end, whatever value you write here as end, you will get one value less. Okay, so one value less means this will be interpreted as 0, comma 1. Okay, so hence we need to go this 2. Okay, you have to write 0, comma 1. So many of you are writing like this. Okay, you're writing. I saw many cases where you're writing 0 colon 1 or 0 and something like this. Or let's say if you do this also, this is not right. Okay, even though it seems that we are writing the same thing, but this would basically say that give me all rows starting from 0. But before the comma, we have to explain what are the rows we want, and after the comma, we have to explain the number of columns that we want. Okay, I hope you have understood. Let me go ahead. Apart from this, apart from slice indexing, we have something called as Boolean indexing. Okay. Just 1 second. Okay. And what Boolean indexing is writing some conditions that returns to us Boolean values. And once we have those Boolean values, we can select those Boolean values so that we get our right selection. Okay, let me show you what I mean. Okay. So first, let me clear my screen a little bit. I will remove all these parts. Now let's say within this program, within this matrix, the same matrix A, I want all the values that are greater than or equal to 3. Okay. If I want all the values that are greater than or equal to 3, within NumPy, I can write something like this. If I write A greater than equal to 3, what this will return to me is this will give to me a Boolean value. Okay. This will give to me a Boolean matrix which has the same size as A and it has for the place where the condition is satisfied, we will get the value true, and for every other place we will get the value false. So we will get false, false, true, 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 true. Okay. So what you'll get is when you write a greater than equal to 3, it will go to all the elements of this go to all the elements of this matrix and find out where the condition is true and where the condition is false. Wherever the condition is false, it will give you a false within the same matrix, and wherever it is true, it will give you true. So you will get this part. Now let's say I want to access these elements. Wherever it is true, I want to extract those elements. I can write something like this. I can write, give me a of a greater than equal to 3. So when you write this part, you are able to access these true elements. Okay, these values that are true elements. Now this is the idea here. Let me shift back to our notebook so that we can see in detail how it works out. Okay. Let me share my screen once again. Okay, so just 1 minute. Okay, so here we can see I'm back here in the notebook and I'm explaining indexing. We have already seen integer indexing above, so we will not take examples of that. Let's take more interesting examples of slice indexing. Okay. So here I'm creating a matrix, I'm creating an array, np.array, which looks like this. So there are 3 rows with 4 columns. The first row has the elements 11, 12, 13, 14. Next we have 21, 22, 23, 24, followed by 31, 32, 33, and 34. Okay. So when you print this array, we can see that it prints it as 3 rows and 4 columns. Excellent. Okay. Now let's say we want to extract from this a certain slice. Okay. I want to extract these values 12, 13 and 22, 23. To extract these values, I'm taking an array. Okay. So I want rows 0 and rows 1. So I write start from 0 and end till 2. Okay. 2 means you will go 1 less, that is 1. That is, this will translate to row 0 and row 1. Within that, I'm interested in column 1 and column 2. So I write the link 1:3, which basically says get us column 1 and column 2. And now from this an array, we are able to extract this slice 12, 13, 22, 23. Okay. So that is how we can extract this slice. Further, you see that this slice and this an array, they link to the same memory location. Okay. They are linking to the same memory location. What does that mean? Is when I will update this a slice, the an array also gets updated. Okay. So let me show you an example. Let's look at this value here, 12. How do I access this value 12? This is in row 0 and column 1 of an array. So before making the change, I am writing before this element is an array, row 0, column 1. So row 0, column 1, it will print the value 12. Okay. Now I update this value and I update this using a slice. A slice has 2 rows and 2 columns. So this element 12 here is basically row 0 and column 0. So when you write a slice, row 0, column 0, update its value to 1000, and then I write the same statement again with after, and I execute this. You can see that, okay, I have to execute the slice before. Okay, you can see that initially we see before as 12, and now after we see as 1000. Even though we are accessing same an array, we have updated a slice, but since a slice and an array share the same memory location, updating a slice also updates an array. When I print an array here, you can see that this value here, instead of 12, we have the value as 1000. Okay. So I hope you have understood. Let me ask a question. How do you think I can extract this slice? I want 23, 24 and 33, 34. What code should I write so that I extract this slice? 23, 24, 33, 34. Let me, as you guys pour in your answer, let me start writing the code. So I have to write a slice and what should be within the first part and second part so that I'm able to access 23, 24, 33 and 34. Okay. Okay, now I've got multiple answers. Mm-hmm. Okay. Okay. So the right answer is you have to see this is row 0, row 1 and row 2. I want row 1 onwards, row 1 and row 2. So I have to write, okay, row 1 onwards. So 1 and colon will start from row 1 and go to the end. Now let's look at columns. So this is column 0, column 1, column 2 and column 3. I want column 2 onwards. So I could write 2 and colon. Okay, so when I write 1 colon 2 colon, then I'll be able to extract, not a slice, sorry, from an array. So from an array, when we extract this, we'll be able to extract 23, 24, 33, 34. Okay. So yeah, that's the part for slicing. Let me go ahead. We can use both integer slicing, integer indexing and slice indexing also. So let's look at an example of that. So here we have the same NP array with the same values, 3 rows and 4 columns, 11, 12, 13, 14, 21, 22, 23, 24, 31, 32, 33, 34. Now, if I want to extract row 1 and all columns, okay, so row 1 and all columns, if I want to extract this part, then I can say go to an array, get us a row 1 column, comma, all columns, okay. So we get row 1 and all columns. You can see that the answer here is this 21, 22, 23, 24. And if you look at the shape of row rank 1, you can see that the shape is just 4 elements. Basically, this is a tuple, okay? And this tuple has just one value. That means we have extracted a row array out of this. Let me show the other example. Here we are writing an array and we are extracting again the same thing. Okay, we are extracting this row, but now we are extracting it using a slice. Here we extracted using integer. Here we are extracting using a slice. The slice says start from 1, end at 2. So when you write end at 2, it will in fact end at 1 less, right? So this will be just the same column, same row as 1 and all columns. So we get row 1 and all columns, that is 21, 22, 23, 24. We can see the values are same, but there is a difference between this part and this part. In the first part, you've got 1 square bracket and 1 square bracket to start and end, whereas here you've got 2 square brackets to start and 2 square brackets to end, which basically suggests to us that this one here is a rank 1 ND array, whereas here this suggests that this is a rank 2 ND array. You can confirm that with the shape. When you look at the shape here, it says there are just 4 values here. And here it says that there is 1 row and 4 values. Okay. So when you extract items or when you slice items using an integer, you will end up with rank 1 arrays. Okay. And when you extract items using slices, then you may end up with rank 2 arrays. Okay. This is a bit important, especially as I said, sorry, I had a power connection and a power disconnection, and this my Wi-Fi just switched off. Let me quickly share my screen, and I'll finish this point. Moment. Okay, great. What I was explaining is, so by extracting from an array as an integer, you may end up with rank 1 arrays, whereas extracting, let me disable annotation and how do I clear it? Okay. Okay. So by extracting using integer, I get rank 1 arrays, whereas extracting using slices, we can get this rank 2 arrays. Okay. Going ahead, we can do the same for columns. So we saw for rows, the same strategy can be applied for columns. And let us just finish this Boolean part. So let's say we have this Boolean part. I have these numbers as 11, 12, 21, 22, 31, 32 as np.array. And I have here these values. If I want to find out all the values which are greater than 15, I write the condition an array greater than 15. So you can see that for the first two, for the first row, these values are false and false, and for the all other values, the values are true and true. Okay, so when you execute this, you can see false, false, true, 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 true. And the interesting thing is, once we have these Boolean indexes, we can extract or we can select our answers by writing an array of this filter. Okay. This filter that I stored here, I can say an array of this filter, and that will help us to get all the values that are true, which is 21, 22, 31, and 32. Okay. Similarly, interesting thing that we can do is, let's say from this matrix, if you're interested to find out all the numbers which are even, that is this 12, 22, and 32, we can do this by using this simple code. We'll say, let's go to an array, which is the big array, and this is our selection criteria. Okay, the criteria is wherever an array modulus 2 is equal to 0. That is, wherever the remainder, when dividing by 2, the remainder is 0, we are selecting only those values, and which we get here as 12, 22, and 32. Okay. We can also do certain operations on them. Let's say you want to do an operation like this. Wherever we find an even value, I want to add the value 100 to it. Okay. The way we can do it is like this. We say an array, and this is our Boolean condition, which is an array modulus 2 equal to 0. And it will select for us all the true values. And within this all true values, we write plus equal to 100. Okay, so we get here 12 plus 100 is 122, 22 plus 100 is 122, and 32 plus 100 is 132. Okay, so those are the interesting things that we can do with integer indexing, slice indexing, and further Boolean indexing. Okay. Since I am getting late for my office meeting, and we are already at a bar of 10 o'clock, we will stop here. And tomorrow, maybe I can quickly revise these indexing ideas of integer indexing, slice indexing, Boolean indexing, and then move ahead to arithmetic operators. Okay. Thank you so much for attending this session. Nisha ma'am, I'll log out now. Okay.
Okay, sir.
Okay. Thank you. Bye bye.
మీకు ఈలలో వెబ్సైట్లో ఎలా రిజిస్టర్ అవ్వాలి అదంతా ఆల్మోస్ట్ అందరికీ ఐడియా ఉందనుకుంటున్నాను. ఇక్కడ ఏంటంటే ఫస్ట్ మీరు రిజిస్టర్ అవ్వగానే కోర్సెస్లోకి వెళ్ళండి. కోర్సెస్లోకి వెళ్ళిన తర్వాత మీకు ఏ కోర్స్ కావాలనుకుంటే అది చూస్ చేసుకోండి. ప్రజెంట్ అయితే మనము డేటా సైన్స్ చేస్తున్నాం కదా, సో డేటా సైన్స్ మీరు చూస్ చేసుకోండి. ఎందుకు మీరు స్క్రీన్ షేర్ చేయడం అండి? సో మీరు డేటా సైన్స్ చూస్ చేసుకోగానే మీకు అక్కడ మీకు డిస్ప్లే అవుతుంది టెస్ట్ 1 అనేసి. సో మీరు అక్కడ క్లిక్ చేయగానే మీకు టెస్ట్ ఓపెన్ అవుతుంది. అక్కడ రైట్ సైడ్ ఒక టెస్ట్ సైడ్ కూడా ఉంటుంది. సో మీరు అక్కడ రైట్ సైడ్ క్లిక్ చేసుకోండి అనమాట. టెస్ట్ బేసిక్ పైథాన్ క్వశ్చన్స్ అని ఉంటుంది. దాన్ని ఓపెన్ చేయగానే మీకు 30 మినిట్స్ అని డ్యూరేషన్ మెన్షన్ చేసింటారు. దాన్ని ఓపెన్ చేసేయండి. అది జస్ట్ గూగుల్ ఫామ్ మాత్రమే. మీ డీటెయిల్స్ మెన్షన్ చేయగానే ఎగ్జామ్ స్టార్ట్ అవుతుంది. 30 మినిట్స్‌లో ఎగ్జామ్ ఉంటుంది. మీరు ఎగ్జామ్ రాయంగానే వెంటనే మీకు ఆన్సర్స్ కూడా అదే మార్క్స్ కూడా వచ్చేస్తాయన్నమాట. ఇంకా నేను మీకు యెస్టర్‌డేనే టెలిగ్రామ్ గ్రూప్‌లో విత్ స్క్రీన్ షాట్స్ మీకు షేర్ చేయడం జరిగింది. ఎలా అనేసి. సో, మీరొకసారి టెలిగ్రామ్ గ్రూప్‌ని చూడండి. ఎలా అని మీకు ఒక ఐడియా వస్తుంది. క్విజ్ కాదు, టెస్టే ఇది. క్విజ్ కూడా ఉంటుంది. ప్రెజెంట్ అయితే క్విజ్ ఏమి అప్‌లోడ్ చేయలేదు మేము. ఫస్ట్ మీరు టెస్ట్ రాసేసేయండి. మీకు అట్‌లీస్ట్ ఐడియా వస్తుంది. ఎంత నాలెడ్జ్ గెయిన్ చేశాము అనేసి. మీకు డైలీ టెలిగ్రామ్ గ్రూప్ లింక్స్ పెట్టాలంటే కష్టమండి. ఆల్రెడీ చాలా మంది జాయిన్ అయ్యారు. ప్రతిసారి పెట్టాలంటే ఇంకేమి డైలీ సెండ్ చేస్తూనే ఉన్నాము. బాయ్స్ టెలిగ్రామ్ గ్రూప్‌లో కూడా చేశామండి. బోత్ బాయ్స్ అండ్ గర్ల్స్. అలాగా ఫస్ట్ టాపిక్స్ వైస్ మీకు బేసిక్స్ ఎగ్జామ్స్ ఉంటాయి. ఆ తర్వాత ఫైనల్ అసెస్మెంట్ ఉంటుంది. మీరు ఊరికే గ్యాప్ లేకుండా ఎగ్జామ్స్ ఎప్పుడుంటాయి? మీకు ఏమైనా చార్ట్ చేసుకోవాలనిపిస్తే పర్సనల్‌గా చేసుకోండి. ఇక్కడ క్లాస్‌ని ఎందుకు డిస్టర్బ్ చేస్తారు చెప్పండి? ఈ ఎగ్జామ్ రాస్తే సర్టిఫికేట్ రాదు. మీకు జస్ట్ ఐడియా కోసం కండక్ట్ చేస్తున్నాం. ఇంకా స్లోగా చెప్పాలా? ఓకే. ఫస్ట్ మీరు రిజిస్టర్ అవ్వండి. ఆ తర్వాత లాగిన్ అవ్వండి. లాగిన్ అవ్వగానే అక్కడ కోర్స్ సెలెక్ట్ చేసుకున్న తర్వాత స్క్రోల్ చేస్తే కింద ఉంటుందన్నమాట. డేటా సైన్స్ బేసిక్ ఎగ్జామ్ అనేసి. దాన్ని చూజ్ చేసుకున్న తర్వాత ఎగ్జామ్ రాసేసేయండి. ఫైనల్ ఎగ్జామ్ వచ్చేసి మీకు ఇంకా హాఫ్ సిలబస్ కూడా కంప్లీట్ అవ్వలేదు. మీకు మేము చెప్తామండి ఎప్పుడు అనేసి.